Very welcome to my presentation. And first of all, actually, again, I would like to thank the organizer for a very interesting event. In this talk, I'm going to present the autonomous monitoring analysis and how it aims to enhance the reliability and durability of the PV systems, and how to contribute to the terawatt photovoltaic transitions. So in this talk, actually, we are going to discuss a bit about the energy transition and the autonomous monitoring analysis and why it's important. And I will give the introduction to the failures in the PV modules, component, and systems. And I introduce also the artificial intelligence technology and the application of the AI. I will give a lot of case studies and also the examples. And at the end, I will introduce to you actually the recent developed software package for the aerial inspection. We call it RoboPV. So regarding the energy transition, so as you know, actually energy transition refers to the global energy sector shift from the fossil-based systems, not only for the energy production, also for the consumption. And so we are actually smoothly try to move from the fossil-based systems to the renewable-based systems. And you can see and observe the energy production by 2050 and middle of this century. And as you can see, there are a lot of progress in the renewable side. So the movement is very clear here. So from the fossil base to renewable base, and the solar energy will be one of the pioneer energy source for this transition. And by 2050, actually, we have a lot of, we need actually much energy, and there will be a lot of demand. And this demand actually will be relied to the renewables, and only the renewables is able to manage this demand. And of course, this transition will have a lot of challenges, and that's not really easy task. And however, actually, different sectors needs to contribute in order to actually mitigate the climate change and also other emissions. So I would like also to show you this very interesting graph, and that's about the timeline of the energy transition. So you can observe here some like milestones or achievement from 2020 by 2050. So by 2020, actually, we had a 6% energy demand drop because of COVID-19. And in 22nd, for the first time, the PV installation reached to the 1 terawatt installation. By 2034, actually, is expected the maritime energy demand will be peaked. And by 2043, actually, at least the half of the world vehicles will be electrical. So that's like the statistics for the futures. And by 2042, actually, the wind will be around 30% of power supply, and solar will be around 35% power supply. And hopefully, actually, by middle of this century, we will have over 51% from the renewable side. And so as you know, actually, the solar photovoltaics is the foremost renewable energy technology for cost-optimized climate change mitigations. And as I said, this is not easy, and we need much installation of the PV. So let's say massive PV installation, so ranging from the 20 to 75 terawatt peak by middle of this century. And by end of the century, I mean, we need around additional 100 terawatt peak. Yeah, here is also the graph of the increasing of the, showing the increasing of the installation of the photovoltaics worldwide. So as you have all actually, I mean, the installation, as I said, also for the first time in 2022, actually we reached to the 1 terawatt installation, and for the first time we passed the annual capacity over the 200 gigawatt. That was actually one of the very great milestone. And but now the question is that why actually we need the intelligence monitoring and autonomous monitoring and analysis. And this question now actually makes sense because we are in the terawatt installations era. So that's something actually we really sense it. As you can see and observe these plants, they are actually, I mean, the most largest plants in around the world. Of course, we have a recent large scale plant over 1 gigawatt installation. So the question is that if you just have a look to this plant, you see actually is needs much efforts in order to do the monitoring. And the question is that how, I mean, it's possible to monitor such a plant, and how many days required to analyze the monitoring data, and how we can actually detect the faults in all the strings, and how would be the decision making for remedial action, and how many days takes time actually to really implement the remedial action, and how also we can actually rely on the outcomes. So for sure, the traditional way don't much help. So we need to actually think about the precise, reliable monitoring methods in order to evaluate the performance of such a large scale plants. And as we are in the transition of the PV terawatt, so we need really to think the intelligence and innovative method for such a capacity. So before going to discuss about the autonomous monitoring and reliability and application of the AI for the PV monitoring, so it would be good actually to discuss a bit about the failures. So in the figure in the left side, you can observe the classification of the faults of the PV systems. So the failures are classified based on the environmental or based on the physical effect and electrical fault. In the DC and AC side can be categorized. And the electrical fault, as you can see in the middle side, including DC like line to line or line ground or mismatching, open circuit faults, ground faults. And however, actually these faults also can be the consequences of some other faults, maybe actually can be appear on the PV panels. And that's important also you consider this and do the monitoring for the both side, electrical side and also the RGB or thermography analysis. However, actually just consider actually this interplay of the stressor on the component and its result of the failure mechanism and their effect on the module functionality and system functionality. It will be very complex and sophisticated. So that's important to actually use the novel method in order to detect better the failures. And most of these failures, of course, actually affect on the performance of the PV systems. And that's important. You detect these failures as early as possible in order to do the remedial action in order to keep the operational ongoing. So here are some examples like delaminations, bubbling, oxidations, and hot spots on the modules. So these kind of actually failures can be detected through the RGB camera or through the thermography analysis. And some of them also can be detected through the data analysis through the normal monitoring systems connected in the AC side or DC side. And according to the statistics, the most failures occur in the PV modules, and some of the electrical faults also initiated from cabling failures and from the external sources. So that's important actually to keep actually monitoring. And in order to keep the monitoring for the larger scale plants, so you need really to apply the AI. And now is the question, what is the AI? And how we can use the application of AI. So in general, AI is a wide-ranging branch of the computer science, considering the building a smart machines capable of the performing tasks which typically require human intelligence. And the AI can actually facilitate this. The AI technology is not, I mean, of course, new, as you can see here in this figure. I mean, the concept started maybe over 70 years ago, but the AI development was very fast in recent years and recent decades. And the reason was actually the data. So access to the data and the availability of the data. And that was the one of the aspect. And another aspect is increasing actually the advancement of the technologies and computational technologies and other technological devices and both sensor hardware and software. So we have several different actually category of the AI. So in general, actually they can categorize as a learning method, as a like a machine learning, deep learning, and so on, and statistical methods and search methods and optimization theory, like a generated algorithm and maybe swarm optimization and grid search, for instance, and game theory and decision-making algorithms. And the concept of the autonomous monitoring analysis for photovoltaics and any, of course, applications is much relied on the application of the AI technology. So here, various faults of the grid-connected PV systems can be observed here in this figure, and most of them actually can be detected through AI application easily. So that could be actually about the AI monitoring for the fault detection on the PV array or strings, and power electronic converter faults can be detected, or fault in the filters or batteries fault or degradation can be detected. And also AI can be part of like other enabling and smart technology like a digital twin. So for your information, the digital twin create an approach for the monitoring and other services for the PV systems or any other systems in real time through the digitalization and virtual world modeling. And this approach uses for the intelligence analysis with the real-time data and gathering the information about the system operating status, and also including the decision making. So the AI has a much contribution also to apply for the digital twin. Typically, the AI, or let's say machine learning techniques, follow 5 steps. So starting from the data collection, cleaning and filtering, and train, of course, selecting the models and training the models, and improving the quality and quality of the data, and at the same time improving the model performance. So in machine learning based monitoring, which can be actually used for the autonomous monitoring, is learning algorithm can be used in order to learn the relation between the output of the different variables of the PV systems. And this train model can be easily used for the autonomous detecting and classification of the fault. And of course, you need the data set, and this data set can be numerical or like a imagery data set, and it depends of the purpose. For the training purpose, we can actually use these models, different machine learning based models, and train the models and use it for the, for instance, fault classification or degradation assessment and evaluations. So in recent years, as you can see, actually, the trend of publications, there are a lot of machine learning methods applied for the detecting the failures, and also for the prediction or classification of the failures, and also use it for the reliability prediction. So in the next slides, I'm going to present to you actually some examples and related to our topic. and you will learn actually more about the how we can use the AI for the autonomous monitoring analysis, especially for photovoltaic system. So here we propose a machine learning based method for the line to line and line ground detection and classification. So we use actually around 1,200 line to line and line ground faults and normal events actually created. We had a system, experimental PV systems development, and also we use actually different method in order to detect the data, collect the data and detect the failures. In another study, actually, we propose a fault diagnosis using the ensemble learning methods, and we use actually the supporting vector machine and navy base and also k nearest neighbor, and also we use it for only to detect the line to line faults. And the accuracy of this method were over 97%. In another study, actually, we developed a novel method in order to detect the hotspot and also bypass diode problem and also disconnected problems on the PV module and strings. We use the conventional methods, I mean, like digital image processing and also the convolutional neural network in order to detect the failures. And also we try to localize the failures, understand actually the localization of the failures that happen, and then do the actions, require action in order to, for instance, send the engineer to fix or do further action in order to understand if the failure is real failure or not. Another example, which is related to the autonomous aerial monitoring analysis, and in order to facilitate the aerial inspection and make it fully autonomous, in order to use it for the larger scale plants, we applied actually the AI technology in order to make the drone and unmanned aerial vehicles as an autonomous UAV or drone in order to make the procedure of the aerial inspection faster and of course accurate. And we have developed several methods in order to detect the failures as autonomous and do the analysis and do the post-processing as a semi-real time. And for this purpose, we develop actually a software package. We call it RoboPV. So this software package is a novel software package for the autonomous aerial monitoring for the larger scale plants. And RoboPV actually can automatically perform aerial monitoring of any plant, completely autonomous from optimal trajectory planning to image processing, pattern recognition, and real-time fault detection and analysis. So there are 6 units in RoboPV, including boundary detection, path planning, dynamic processing, fault detection, autonomous maneuvering, and decision making. So in boundary detection, which is very important step, for RoboPV, actually, we use it for the improve and optimize the path planning during the autonomous aerial inspection. And we develop different algorithms using the digital image processing and deep learning techniques in order to improve the reliability of the boundary detection at the first stage of the autonomous monitoring. You see here some example of the plants for how actually RoboPV is able to detect the boundaries of each plant accurately in order to initiate the next step, which is the path planning. So we use actually several, we develop actually new data sets, and this data is available in the IEEE data port. So feel free to access it, and including the codes. So this data set, including around 3,500 aerial images from different plants in order to use it for the training our models. So the next unit is the path planning. So in Autonomous aerial monitoring for plants, for PV plant, drone must fly over the set of waypoints which cover whole area of the plants. And that's very important and essential to have a specific path planning algorithm in order to create the optimal paths for the PV plant aerial inspection. So that's why we developed like this unit for the RoboPV. So as you can see here, different plant has a different path planning models, and that's based on the waypoints we can detect it from the each plant. Another unit is a dynamic processing unit. So we develop a dynamic path planning algorithm for autonomous maneuvering of the UAV during the aerial inspection. For this purpose, actually, we access to the flight computer of the UAV, interact with the onboard microprocessors on the UAV, and connected through API to the RoboPV. And through that, actually, we're able to send the command to the UAV, and in order, for instance, to the action if required. For instance, we define several modes like a home mode, flight mode, and maneuvering mode, and through that we try to use it for during the flight in order to make it more accurate and of course more safer. Uh, we had another unit as a fault detection. So RoboPV also including the fault detection unit in order to detect the failures, any failures which can be detected through the different sensors like RGB or thermal sensor or EL sensor. So we developed several algorithms in order to detect the failures. So here is an example for the detecting the bird drop failures. Another unit is actually the maneuvering unit, and that's also very important. Um, During the mission, whenever actually any failures detected, the drone automatically can just detect it and then try to reduce the altitude in order to provide better overview for the detection, and also maybe better analysis, real analysis. And this maneuvering unit is responsible for this action. So, and after actually do the take a further investigation, the drone can back to the pass and continue the mission. And there is another unit as a decision making. So during the flight and of course after the flight and landing the drone, that's important actually to do some action. And this unit responsible for the make a decision for the aerial flights and also for the detecting the failures and so on. I would like to show you a simulated version of the RoboPV. Of course, we tested in the real time, but here you can really sense what how actually RoboPV works. So here there is a plant, and this is a pass of the pass flight of the flight, and you can see only there is a failures here. So I would like to just run it. You watch it, what's happened. So in this plant, actually, the string only affected by one faults, and you can see when the fault detected by the UAV, and the UAV has a maneuvering and try to reduce the flight altitude to 5 meters and above the ground, and it depends of course the condition of the plant, and investigate accurately and detect the failures. I would like to show you another example with two failures. So the flight started and the drone, starting and followed the pass. And after reaching to the first fault and after recognize the faults, it's tried to actually reduce the altitude and then just detect the failures and accurately and continue, and then the next, and then detect the next fault and then continue in order to yeah, fulfill the mission. And here is with the tree. Yeah, since I don't have much time, so I will try to skip. Yeah. So let's just summarize what we discussed. So as we discuss about actually the failures and the reason of the failures, and we discuss about the energy transition and increasing the number of the PV installation. And we are in the terawatt peak transition. And as I said, by middle of the this century, we need actually to reach to 20 to 75 terawatt installation in order to contribute to the energy transition. So recent developments actually aim to increase application of the AI, and of course we can use the AI application in order to detect the failures, any malfunctions or any other problems faster, precisely, and this is help. This is something actually can really help to increase the reliability and durability of the PV system and increase the lifetime of the PV system. Autonomous monitoring and analysis is the novel concept in order to integrate different techniques, devices, and systems in order to facilitate the PV monitoring for large scale plants. And that's very useful for the terawatt PV era. And also I introduced to you actually the RoboPV as a software package for autonomous aerial monitoring of the plant. Before finishing my presentation, I would like to introduce to you actually our program in University of Freiburg. We have a continuation master degree program on solar energy engineering program. And that's in cooperation with the Fraunhofer ISE. So University of Freiburg is one of the 10 University of Germany, and also the Fraunhofer ISE, as you know, actually is the largest solar energy research institution. So we have this program based on our collaboration with the University of Freiburg and Fraunhofer ISE. So that's it. So thanks a lot for your attention, and yeah, feel free to ask your question. And also, if you want to have a collaboration with me, reach out to me through these emails.